Good evening, good morning. It feels like evening sometimes when you've been traveling. But good morning to you all. I guess the first thing I want to say is I want to thank Samer and Hussam from the Center of Excellence in Learning and Teaching Innovation, which has started recently, for their invitation here, and obviously for Dr. Marwan for the invitation. This is my, I think, 4th time to PTUK and 10th time to Palestine. I feel like it's a second home now. I wish that I spoke more Arabic, but I do feel I'm beginning to get the rhythms of Palestinian higher education. I'm particularly impressed by how much change has happened in the last 5 years. I've seen a lot of the work that's happening here, and it surpasses much of the work that's happening in my university at the United States. Even though we've been working on it longer, there's still a lot of change. And in fact, one of the things I wanted to talk about today, is a project that we've been working on for about 12 years at the Searle Center. It's a project that's gone national in many ways. We've probably published about 17 papers on it, so we've assessed it and evaluated it in some detail. And we've written a book about it, and I'll talk a little about this. And it was originally started in some ways to minimize what faculty had to do in the large introductory courses called gateway courses in the sciences, engineering, and math, which at Northwestern, and I think in many universities, are traditionally the most difficult to get to change, partly because there are 200 students in the class. Most of the faculty teaching the class are research faculty. They don't think they have a lot of time to make change. So we picked up on this idea, and we picked it up from a number of different sources, of having students engage in promoting their own learning with some faculty input, and I'll show you what I mean in a moment. When we assessed this, we found that there were a huge number of lessons that we'd learned about what we can use to transform teaching within the classroom. So this is the overview of what I'd like to talk about. I'm going to talk about this large-scale innovation in science, technology, engineering, and math. Is that better? Okay. It's a large-scale innovation in science, technology, engineering, and math. Many of you know those are the letters for the word STEM, which is widespread in the United States to talk about science-related courses. I'd then like to talk about some of the data that we got back on student learning, because at the end of the day, we were interested in the impacts on student learning and on the impacts on students remaining in the courses. The second bit of data I'd like to look at, and I'm just going to give you an idea of the principles that we learned when we went through all the qualitative data, not just the quantitative data, but the qualitative data, interviewing students and faculty about what were the things that worked most for them. And we came up with 6 principles, which I'd like to share. And then I'd like to talk a bit about using these principles in action. So I want to share a few examples of how these principles have been used in teaching and learning to improve teaching and learning. And I will focus on the data as well as we go, because this area is a new science. In the United States, it's often called a learning science. It's a new field of education. It needs to be rigorously researched. Practitioners in it, and that means teachers if they engage in it. Not every teacher has to engage in it from a research perspective, although we asked all of but these were their own grades, their own exams. We adjusted them for SAT, which is a high school entrance exam that every American student uses. And they all do the math exam. And so we wanted to make sure that we were adjusting them so that, because some faculty would think, well, you've just taken the best students. Only the best students came into these classes. So we said, okay, well, we'll adjust these for their math scores.